All right, so what is the area of the square? The orange square inside?
C squared.
C squared, all right. So the area of this is C squared. What is the area of this triangle right here?
AB squared.
It's not AB squared. How do I find the area of a triangle?
Oh, AB
Oh
over
wait,
2.
I thought you said this.
It's AB divided by 2, right? Because the area of a triangle is base times height divided by 2. All right, so what is the area of this triangle right here?
All of the triangles are AB over 2.
Oh, okay, all of them are the same. So would it be fair to say that the area of the blue square would be the area of the 4 triangles plus the area of the square in the middle?
Yep.
Okay.
Just did AB squared.
So we have 4 of those triangles, and that's AB divided by 2 plus C squared. Do you agree with me so far? Okay. And what is 4 times AB divided by 2? It's not a trick. 2AB.
2AB.
So the area of this blue square is 2AB plus C squared. Yes? But there's another way to find the area of a square. I could do base times height, right? Okay, so I could say and yeah, Walter, you're right. A plus B times what?
A plus B.
A plus B.
So A plus B squared.
Or A plus B squared. Now I'm going to write it as A plus B times A plus B because it's easier to multiply that way. In case you don't remember the rule of A plus B squared. So, oh, this is just like what we're doing in algebra right now, isn't it?
Yep.
Yep. So what is A times A?
A squared. A squared.
What is A times B?
B squared. AB.
AB. B times A?
BA.
And we're going to, remember, it goes alphabetically, right?
Sure. So AB.
Okay, and B times B?
B squared.
All right, so you add those together and you get A squared plus 2AB plus B squared, which if you remember the rule of a square binomial, that also works. So we have 2 different ways of finding the area of this blue square.
Yep.
Well, what does that mean about A squared plus 2AB plus B squared, and
They're equal.
it means they're equal.
Well,
So let's go ahead and write them equal. A squared plus 2AB plus B squared is equal to 2AB plus C squared. So
B squared has to equal A squared plus B squared.
because we have 2AB on both sides, right?
Yep.
So they cancel out, which means A squared plus B squared must equal C squared.
Oh, and that's the Pythagorean.
And that's how we prove that the Pythagorean theorem has to be true. Just using basic algebra. So, that is how we know A squared plus B squared is equal to C squared. And there are some other ways that we could prove it as well. This is probably the most elegant and easiest to understand, as long as you have a good understanding of basic algebra. So, are you good so far?
Yes.
Okay, so we are going to be using A squared plus B squared is equal to C squared to answer some problems. Plus, we're going to add one other theorem on top of it. And because we're dealing with area, and area is squared, we're going to have a bunch of quadratic problems thrown in with it, because we're going to be squaring variables. So I do want to take a moment and refresh your memory, because I know that we're going to have some mathematical errors. Now, notice how in this problem, I didn't want to write a plus b squared. I said I want to write it out a plus b times a plus b. Here's why. So I'm going to show you a very common misconception, and then we're going to work to try to prevent that from happening. So let's say we have c minus b squared. So we have Claire minus Brown squared. What does that mean? Now, the most common mistake, it's a huge mistake in Algebra 1. A lot of people are going to want to do this. Oh, so this is c squared minus b squared. That is not correct. Do not do that. It is not good. Applying this exponent inside of parentheses only works. This strategy only works when you're taking a monomial to a power. But we don't have a monomial. We have a binomial. Bi meaning two, nomial meaning terms. So in other words, what that means is when you are squaring something, you have to multiply it by itself. So that's c minus b times c minus b. So that's why I wanted to write out a plus b times a plus b instead of a plus b squared. I wanted to make sure we remembered we have to multiply a to a and b to a and b. And so if I were to multiply this out, I'm again going to get c squared, since it's a minus 2cb plus b squared. Very similar to what we had over here, isn't it? The only difference is because we have the negative sign, the linear term is negative. Now, also let's do a quick little reminder of some vocabulary for quadratics. This is called the quadratic term because it is squared. If you graph just c squared, you will get a parabola. This term right here is called the linear term because if you were to graph it, guess what shape you get? A line. And this is finally called the constant term because it doesn't change. But in this case, it's a variable, so that's not quite the case, but whatever. So when I say linear term, that's what I'm talking about. All right, so Avery and Claudia, are we doing okay?
Wait, what was the b one? B squared?
So typically that's called the constant term because it's a number that doesn't change. Now this isn't a number, so it's a little bit different.
Right.
Okay. All right. So I think we should talk some problems here. Shall we?
Sure.
Okay. So I'm going to draw a triangle, and I would like you to solve for x. So let's say we have this triangle. And obviously the Pythagorean theorem only works for right angles. So we have to assume that this is a right angle. And this drawing is not to scale. If this side length is 4, this side length is x, and this is x minus 2, what is the value of x in simplest radical form? Simplest radical form. So the big difference between this problem and problems you've seen in the past is instead of having one variable for a side length, now you have two.
Two.
All right. So Claudia, do you mind setting this up for us using the Pythagorean theorem?
So wouldn't it be 4 squared plus x minus 2 in parentheses squared equals x squared?
Okay. All right, so let's simplify this a little bit further. So 4 squared is?
16.
All right, and I'm going to go over on this side because I have a little more room. What's another way of saying x minus 2 squared?
X squared minus 4.
You just fell into the trap.
Oh, x squared minus 4x plus 4?
So when you're squaring something, it means you're multiplying it by itself, right? So we have x minus 2 times x minus 2.
But what? That doesn't make any sense. In algebra, we're doing. Well,
Claudia, the
Claudia,
whole term is squared. So if you have 2x minus 2's and you multiply them together, so it's say x minus 2 is just like 5 instead. It's it's 5 squared, but it's x minus 2.
so Claudia, the example the thing that we're talking about in class today was a difference of squares. Notice how it was a different sign inside the parentheses.
Oh, okay.
Whereas now the sign is the same, and that's the difference between what we did in class and what we're doing right now. So this again is, hold on a second, this is again is called a difference of squares, and that's fundamentally different than this, which is called a square binomial.
Okay.
Okay? But you are good to see the connection between it because they are very similar. All right, so what is x minus 2 squared?
I got x squared minus 4x plus 4.
Because it's this squared, and the middle term is 2 of these two multiplied together.
Yep.
Okay. Now, this actually doesn't look too bad, because what's the first thing we're going to do?
Cancel out the x squared.
We're going to cancel out the x squareds, that's right. So we get 16 minus 4x plus 4 is equal to 0. All right. What is my next step?
Add 4 and 16.
Add 4 and 16.
And you get 20 minus 4x equals 0, and then you have to add 4x.
Sure.
So 20 equals 4x, and then x equals 5. X equals, yeah. Okay.
So Claudia, out of curiosity, and Avery, is it helpful to see where these quadratic principles come up later when you're learning those quadratic principles? Thank you, Karen. Have a great day. Do you like to see the next iteration?
Yeah, I don't know, it's still, but, okay, so if what we were working on in class, how do you determine whether it's going to be 2 negative signs or 1 negative sign and 1 positive sign?
Okay, so I'm going to stop the video for that, and then I will answer your question, okay?